Hi, everyone. In today's lesson, we're going to talk about a concept called the second derivative test. And what the second derivative test does, it tells us if we have a maximum or a minimum value at any specific critical point x. So it's really important that you highlight or underline this critical value x. So what the theorem states is that if you take the double derivative or the second derivative of the critical value, then if that value is greater than 0, then we have an relative minimum. And at that critical value, x, okay? If f double prime of that critical value, x, is less than 0, then that means we have a relative maximum. So it's kind of opposite of what you think it is, right? Greater than 0, you would think maximum, but less than 0, you would think minimum. So greater than 0 is actually a minimum, and less than 0 is actually a maximum at that specific critical value. So it's just a faster way of finding maxes and mins, and then theoretically we can find intervals of increase and decrease as well. So let's take a look at example number 1. So we've got this function f of x, and I want to find, using the second derivative test, where I have a maximum or a minimum. So the first thing I need to do is find the critical values. And remember, the critical values is where f prime of x is equal to 0. So first let's take our derivative. So using the power rule, the derivative of this is 4x to the third plus 6x squared minus 4x, and I'm going to take that derivative and set it equal to 0. So I see that I could take out a GCF of 2 and an x, and I'm left with 2x squared plus 3x minus 2. And I can keep factoring using guess and test. So I've got 2x and x, and I need the factors of 2. So I'm going to guess and test and see what happens. So if I put a 2 here and a 1 here, this will multiply to 2, this will multiply to 2, and 2 is not going to give me 3. So let's try again. So I'm going to erase this, and I'm going to erase this, and I'm going to put now 1 here and 2 here. So this gives me 1, and this gives me 4. Well, I can definitely get a 3 out of that if I make this a positive 4 and a negative 1. So now I've got 3 values for my critical. So I've got x equals 2x equals 0. And to solve that, just divide by 2. So I've got x equals 0. This one is 1/2. And this one is negative 2. So if I want to find if I have a maximum or a minimum value, all I need to do is plug these answers that I got here, which I'll label in green to show you their critical values. You got to plug these values into f double prime. So the second step, plug critical values into f double prime of x. So let's find f double prime. That means to take the derivative of the derivative. So we're going to take the derivative of this piece. So f double prime, I'm doing the power rule of this. So 12x squared plus 12x minus 4. And what I can do now is set and plug in my values. So I'm going to plug in 0. And then I'm going to plug in 1/2. And then I'm going to plug in negative 2. So 12 times 0 squared plus 12 times 0 minus 4. 12 times 1/2 squared plus 12 times 1/2 minus 4. And then plugging in negative 2 and getting 3 values. So why don't you take a minute, pause the video, and plug these 3 values into the calculator and see what you get. And then hit resume when you're ready for the answers. All right, this is what I got. All right, so because our first value, when I plugged in 0, I got a -4. And since -4, when I plugged into my double prime, my critical value, since it was less than 0, that means I have a relative max there. So here, if we want to label, this one is going to be a max. Now the second one, I got put in a half, I got out a +5. So look up here. When x is greater than 0 or positive, I have a relative min. So we're going to say that this is a minimum. And then again, when I plugged in x is -2, I got out +20. And +20 is a value that's greater than 0. Therefore, I have a relative minimum. So I want to find the actual values for the minimum. So step 3, to find the minimum values or maximum values, plug in the x values of max and min into the original function, so into f of x. Whenever you're trying to find something about the original function, you're always going to plug into that original function. So we'll highlight the original function here up in blue, and then that's where we're going to plug into. We're plugging into our original function. So to find the coordinates of the max, we're going to plug in this is a max value. We're going to plug in 0. So I'm going to write down what we're going to plug in. So we're going to plug in f of 0. Then we're going to plug in f of 1/2. And we're going to plug in f of -2. So again, you're using the original function. So if you want to go back up here, you absolutely can. And you're going to plug in to this guy. So 0 to the 4th plus 2 times 0 to the 3rd, 2 times 0 squared, and then plus 6. Now, same thing, you're going to plug in a half. Everywhere I see an x. And then you're going to plug in -2. So take a couple seconds, pause the video, and then hit resume when you're ready for the answers. All right, this is what I got. So I got 693/16 and -2. So if you want to put these into points, you have to put the x value that came first and then the y value. So we put in an x value of 0, got out a y value of 6. So this would be the point 0, 6. Then next we put in an x value of a half and got out 93/16. So 1/2 comma 93/16. And then -2 was the x value we put in, and we got out a y value of -2. So -2, -2. So at x equals 0, we had a maximum. So here is my max. And then the other two are my minimum values. Now, I know the directions say to use the first derivative to find where it's increasing or decreasing, but you could actually, in here, step 4, find the values of increase and decrease. And the way you can find that is by drawing a sketch. So let's see. If you have your f prime number line and you put your critical values, right? So your critical values were -2, 0, and 1/2. So the sketch that you can draw will really be able to help you. So if we know that we have a maximum at 0, it's going to be 0, 6. So somewhere up here we have a maximum. And then we have a minimum at 1/2 comma 93/16. So that's probably going to be somewhere over here, still positive. So this will be another minimum. And then at -2, -2, which would probably be somewhere down here, this is going to be another minimum. So in order to get a minimum, you kind of have to sketch the curve a little bit. So to get a minimum, it's going to go down and approach it. Then it goes up to the maximum and then down to the minimum. So in order for this to be a minimum, I can't keep going down. I have to go up, right? To create my minimum value. Here's a relative max. Here's a relative min. So you can say the graph is increasing from -2 to 0 and from 1/2 to infinity. So increase from -2 to 0 and 1/2 to infinity. And then you can say the graph is decreasing. So from here to here and from here to here, the graph is decreasing from -infinity to -2 and then from 0 to 1/2. So decrease from -infinity to -2 and from 0 to 1/2. So you can actually get a lot of information from the second derivative test. You can find maxes and min values, and you can find increasing and decreasing. So why don't you guys take a minute and try question number 2 on your own. It's on the back page. And then we can start by going over this one in class tomorrow. So we'll say that this one is homework. All right, have a great night.